Welcome back to my channel, everyone. Today we're diving deep into a topic that's both fascinating and crucial, especially for those in engineering, design, and really anyone who cares about safety. We'll be exploring the concept of single-point failure. Now, this isn't just some abstract engineering jargon, it's a concept that has real-world implications, and understanding it can be the difference between a near miss and a catastrophe. Over the years, there have been several high-profile accidents that were, at their core, caused by a single-point failure. We'll be looking at 3 specific accidents, dissecting what went wrong, and more importantly, what lessons we can learn from them. Remember, knowledge is power, and in this case, it could even be life-saving. Let's start with the Tenerife airport disaster, which occurred in 1977. 2 Boeing 747s, KLM and Pan Am, collided on the runway, resulting in the deadliest accident in aviation history. There were numerous contributing factors, including dense fog that severely limited visibility. But the critical single-point failure was a miscommunication in the final moments before the KLM flight attempted takeoff. The KLM pilot, due to a combination of factors like radio interference and misinterpreting instructions, believed they had clearance to take off. However, the control tower had not given the final clearance, leading to a fatal misunderstanding. The Tenerife disaster highlights how crucial clear and unambiguous communication is, especially in high-pressure environments with little room for error. It serves as a stark reminder that even with multiple safety layers in place, a single point of failure can lead to unimaginable tragedy. Our next stop takes us to 1986, to the Chernobyl nuclear power plant disaster. This event, etched in our collective memory, was a catastrophic nuclear accident caused by a flawed reactor design combined with human error. The Chernobyl reactor had a design flaw where a power surge during a safety test led to a rapid and uncontrollable chain reaction. The reactor's emergency shutdown system, designed to prevent such scenarios, was poorly designed and actually worsened the situation. This design flaw, coupled with operator errors and a lack of proper safety culture, created a perfect storm. Chernobyl underscores the paramount importance of robust safety systems, especially in high-risk industries like nuclear power. It serves as a chilling reminder that even seemingly small design flaws can have catastrophic consequences when they become the single point of failure. Chapter 3. Challenger, a failure on solid ground. Now let's shift our focus to 1986 and the Space Shuttle Challenger disaster. This tragedy unfolded live on television, shocking the world and exposing flaws in the decision-making process within NASA. The Challenger disaster was caused by the failure of O-rings, rubber seals in the solid rocket boosters, which lost their elasticity in the unusually cold temperatures on launch day. Engineers had raised concerns about the O-rings, but their warnings were tragically ignored due to a combination of factors, including pressure to maintain the launch schedule and a culture that discouraged dissent. The Challenger disaster serves as a stark reminder that ignoring engineering concerns and prioritizing expediency over safety can have devastating consequences. It highlights the importance of fostering a culture where safety is paramount and dissenting voices are heard and taken seriously. Outro lessons learned, lives saved. As we've seen, single-point failures can manifest in various forms, from communication breakdowns to design flaws and cultural issues that silence dissent. But the common thread is that they all represent a critical vulnerability within a system. Understanding this concept is not about dwelling on past tragedies, but about learning from them and preventing future ones. It's about cultivating a mindset that prioritizes safety, encourages open communication, and values thorough risk assessment. Remember, safety is not a passive concept. It requires constant vigilance, critical thinking, and a willingness to learn from both successes and failures. If you want to learn more about safety and design principles, I highly recommend checking out these resources.